just do go to this sites. The site name is sites.google.com.view. I mean slash view slash unit college. I think you have got this. You click on the site. In case if you need the notes or the slides, as I've already told you, go to click on BCA. You can go down, check this notes. Okay, from notes you go to SC paper. So you can find the slide here. So this current slide which I am doing is this is the one, unit 2 part 1. Okay, and to get the link of this live class, you can click on this classes at the rate live. You can see all the links here. So this link I'll paste it after I finish the class. Okay, so that's the thing. And to submit the assignments, some of the students, they told me that they have some issues here. There's something called as upload assignment. So give your name. Problem here is sometimes it will ask you for Gmail ID, and it says that your space is getting less. Then you just cancel that part. Okay, and you just finish. I can see here that there are 21 responses here of all the responses which I have received. You can see the slide data here. You can see a name here. I men lang Karmalki Bahun lang Casper Diamond Iba Ribalang Tabor, okay, Wandahun, and the students. I can see this. You have submitted your assignments here. These responses I can check from here only. Okay, anyway, that is not your part. So in terms of roll number, these are your roll numbers. Is it 2502 and all? Okay, that is for this part. Now to continue with the class, in case if you have missed this, you can go back and check. So I'll just start in 5 minutes. Okay. Yeah, in case if there is a slack here, if you find that there is slacking, what you can do is you can just go a little bit behind. Okay, you can just go behind the. So I'll just start in 2 minutes from now, 2 to 3 minutes. So let me see if others can log in. Yeah, if you find any latency is there, so or I'm having some lagging, you can just go behind a little bit, 5 to 10 seconds, and just check. And in between, I'll pause. Okay, so I'll start at exactly after 2 or 3 minutes from now. Okay, so in just be there. So just give your attendance here. I'll just be here in 2 to 3 minutes. Okay. Okay, so can I start? Okay, Casper saying please upload this after you have finished the class. Okay, don't worry, Casper. I have been uploading all of the videos. You can check from the link. You can get it from this link, this classes live. If you click on this classes.live, so you can see fourth semester topic of 18th and 19th March, and there onwards, all this I have uploaded. Okay, so okay, then it's fine. I'll start the class. Okay, this is a short class on a very important topic. The topic here is the waterfall model. Okay, okay, we have seen this model. This is called as a classic waterfall model. Okay, now two things are important here. Sorry, just 1 minute. This something called as this process. Okay, you have to know this something called as process. The process means whenever we do anything, it has to follow a process. So if you prepare a tree also, I mean a tea, you're preparing tea, it has a process. First you warm the water, then you put tea leaf, then you add sugar and all, then you boil. Okay, there is a step of process. So process means a series of steps that whenever we do any activity, then there is a series of steps. Now there is something called as constraints. Okay, so when you cook, when you're preparing a tree, you are in some kind of constraints, like you cannot add uh, sugar for a diabetic patient, so it's putting your constraint. Is it? That means you cannot do that. That's a constraint. And you have the list of resources. That means the saucepan, the tea cups, which will prepare you the tea to give you the intended output. Okay, that's a process. Process means set of activities which follow some constraints to give you the output. Now there is something called a software process also. A software process is also a set of related activities that help us in developing a software. Okay, so process and software process. Okay, now whenever we do a software process means it follows some model. Okay, this process model, we have a set of process model, and one of the first traditional process model is what we say is this one, the classic waterfall model. Okay, so this is the topic today. So just tell me if I can start now. the topic today. Okay, so I start. So Tabor is ready. So I hope others are also ready. So I start. Okay, fine. Now, whenever we do a project, the first thing we always see is you have to remember this point. Okay, the first thing is we check whether the project can be done or not. Feasibility study. Then comes the requirement specification. Means what are the things we require to do and what are the specification we write in a paper. Then we design a model or we design the system. After that, we have to write a program to design the system. That means, and we test it. Then different parts are integrated together. And finally, once it is developed, we have to do the maintenance. Now, this I have done in the I have told you in the previous class also. This is the basic model for any software design or even in any engineering design. Okay, all other models they follow this basic rule. Okay, now I have given you example of something like a the librarian, is it? And I have also in the class I have given you an example of making a shoe, that is a shoemaker, is it? I have given you this example. When you go and make shoes, what happens is first we have to tell them I want to make this shoe, then he'll take a design of it, then he'll test whether you have enough money financially or not. Okay, so I'll just read out through these slides. Okay, now the classic waterfall model, the different phases of classic waterfall model. Okay, now the classic waterfall model is intuitively the most obvious way to develop the software. Though the classic waterfall model is elegant and intuitively obvious, it is not practical mode in a sense that it cannot be used in actual software development lifecycle projects. Thus, this model can be considered to be theoretical way of developing a software. Okay. Now, this is the most theoretical model, though sometimes it is used, and in practical projects sometimes we don't use. But this is the most basic and theoretical model we have seen. Now, activities taken under the first phase, that is what happens in a feasibility study. We all know what is a feasibility study, is it? Whether the project can be done technically, financially. Okay. Now, feasibility study is to determine whether it would be financially and technically feasible to develop the product or not. That means whether we are financially and technically sound to make the project or not. That is what we call as a feasibility study. And activities taken around during this feasibility study is also this two terms. One is the technical feasible thing. Another one is whether we have the finance or not. Okay. Now, rough understanding between the team members about the estimate based on the client side requirement. So a rough estimate is made whether this much amount or this much technicality we have, so we can build or not. After overall discussion, they search for variety of solution on the basis of kind of resources at the time of requirement. Now, basically what we know here is we have to check in feasibility study whether it can be done or not, and a rough estimate is made. Okay. Now there is overall discussion between the team and the user for variety of solution. If they have any problem, can we do this, can we do that? So if financially it is down, so we take some kind of solution on the basis of kind of resources and the time requirement. Okay, so that is the first phase. So any questions still here? I just give you a pause for 30 seconds. kind of solution on the basis of kind of resources and the time required. Okay, Casper is saying me that he doesn't have any question right now, so I'll just proceed from here. Okay. Okay, Teburlang, he is giving a problem, saying that there is a problem with the audio. Okay, now Tebur, if you have an audio problem, you just go a little bit, just go back a little bit. Okay, okay. So I'll just start from here. So we have seen that what are the activities we take in the feasibility study case. Okay, that is two things. We check the technicality and we check the finance and other issues in terms of times and other resource which is availability. Now, the activities taken during this is the the main part is of this feasibility studies. We check whether the finance and the technicality and other requirements, whether we have the other resources and the time or not. Now next comes is what we say is the requirement analysis and specification. Now activities taken under this, the aim of requirement analysis is to find what are the exact requirements of the customer, what does the customer wants, and to document them properly. That is the thing. Okay, now this phase to understand customer needs, we have two things here. One is called the requirement gathering and analysis, and the next one is called as the requirement specification. Now the goal of requirement gathering activity is to collect all the relevant information from the customer. What does he want, how much computers they want, which software they have, the customer needs. Okay, now this is done clearly on the understand the customer's requirements. Now unless and until we understand customer requirements, that what type of shoes he want to wear, we cannot develop that shoe. So in case of software also, what type of software he wants, whether he wants a library automation software, okay, whether he wants to build a calculator for library, we don't understand. So the customer will tell, the customer means the user will tell what are the requirements, and we will also try to see all the inconsistencies and incompleteness. Now customer will say that I just want software of this type, but whether he what he wants to say is a complete thing or not, and whether what he says is consistent or not, because inconsistency means today he says something, tomorrow he'll say something else. That is inconsistency. Okay, so that is the first thing we see during the case of requirement analysis. So a requirement means we just try to gather what is the customer's need. So we see what is the requirement analysis and requirement specification. Now after all the ambiguities, now ambiguities means sometimes the customer is telling one, sometimes he is telling that it is two. Now that is an ambiguity. Now he must be very sure that he, sir, this is one or this is two. Okay, that is ambiguity. Inconsistency means today his demand is A, after some time his demand is becoming A dot B. So that is an inconsistency. Okay, and incompleteness. Okay, after all this have been resolved, so we go to a document writing. We'll write everything in a piece of paper, or we make a diary or document. That document is called SRS. SR means software requirement specification. So you go to a somewhere to build a clothes. So the tailor will take your all your measurements. He'll ask what type of thing you want. Say, sir, I want a 3-piece suit. Okay, the tailor will say, fine. Okay, do you have the money? So that means he's calculating his feasibility in technicalities and finance. Now at the end, okay, fine. What is your measurement? He'll take the measurement and write in a piece of paper. That is, he's documenting your need. That is called as SRS. Okay, software requirement specification. So all the customers' requirement is written in a SRS document. So first thing is your feasibility study, that is finance and technicality. Second thing is the requirement gathering. That means the customer will give you all the requirements. The third thing after the gathering in the same phase is SRS document. That means we'll have to write all the gatherings in one document. Okay, so I just pause here in case you have any questions before I go to the next phase. If you have any questions. If you have any questions. Any questions? That is finance and technical. Okay, Nikki is telling that the audio is not clear. If the audio is not clear, you just go behind the video for 5 or 10 seconds. Just go behind, because the live audio sometimes is not clear. I know, because even I am checking that. Yeah, just go behind 5 to 10 seconds and check the video. After few minutes I'll take again, and in between if you have any questions I'll just take a break for 2 minutes. Okay, so I go ahead from here onwards. Okay, so we have seen here two things: feasibility study, where we talk about one is the technicality, and next thing is the finance and other requirements at that point of time. Then we see the requirement analysis of the person. Requirement analysis says this: what does the customer needs? There's a needs of the customer, and everything is gathered from the customer end, and it is put in a document that is called as specification document, that is called as SRS. Okay, now we come to something called as a design. Okay, activities undertaken during this design form. Now the goal of the design phase is to transform the requirement written in the SRS into a structure that is suitable for the implementation in some kind of language. During the design phase of the software, architecture is derived from the SRS document. Two distinctly different approaches are available: the traditional approach and the object oriented design approach. Yeah, I'll come to this one. Now, this is done. Whatever is written here, the customer wants to build a shoe. Okay, his requirement is to have a shoe. The size of shoe, everything is noted down in the SRS document. Now, once that shoe comes, we have to design this. Now, whatever is there in this requirement of this, we put it in an SRS. Now, whatever is written here in the SRS, we have to make a design of this. Okay, and this design has to be done in some type of a language. Now, it can be done in a traditional language like C, or it has to be done object oriented language like C++. Okay, that's part of the design. Now that means we have to do a design here, we have to make the model. Okay, that's about the design phase. Next is what we call as a coding. Coding means writing program. The purpose of coding is to write or develop the software, and the purpose of testing means testing the system. That's it. That means you run the system and test it. Test basically means you compile, check errors, and run. Okay, now each component of the design is implemented as a program module. Now see, for example, if you want to develop for a shoe for a customer, so when the shoe whole thing is tested for the customer, this is the shoe, this is the heel of the shoe. So when we test the shoe, and there is a lace here, so in module testing what we do, we test the heel, we test the lace separately, we test the shoe, we test every part differently. That is called as module testing. Okay, now after testing comes, we have to integration and system testing. Now integration and system testing, I'll not you read the slide, I'll just show you. Now, each of these parts, say for example the heel is tested, the lace of the shoe is tested, the shoe front end is tested. Each of these part are being joined together. Now when we say it join, that means it is joining, means it is integration. Okay, means different parts are brought together and integrated. That is assembling. Okay, that is about what we call as a system testing. So unit testing means you are testing each part of the software. System testing means you are testing the whole part after you join. Okay. Okay, now this testing, it has of two types. One is called alpha testing. This is done by the people who develop the software. Other one is called beta testing. That is done by the customer himself. Now last is another one is called as acceptance testing. It is the system testing performed by customer himself, whether the customer accepts the product given by the trailer or the development team after it is developed, and whether the customer will accept or he may reject the delivered product. So alpha, this testing will do in detail. So alpha means development team, beta means the by the development team, and acceptance testing is acceptance means whether the customer is accepting the product. Okay, so we'll just see this one. So in the feasibility part, we see the technicality and the finance. In the SRS, we see the requirement gathering. We gather all the requirements of the person, and we put in a document called as SRS. Then after that we design. When we design this, we have use in some kind of language, we write the code and we design. It can be traditional approach of just writing program, or if we develop object oriented programming. Now if you have done Java, you'll create object, that is object oriented program. If you do in C, then it is called as traditional approach. Okay. Then finally when it is done, we write the code and we test, then we integrate, and finally what is called as the maintenance. Now just see the maintenance part. We'll just see here. Maintenance part of a typical software requires much more effort than to development the system. Now maintenance means, this is the one of the most, maintenance of a typical software product requires much more effort than effort to develop. Okay, that means when you make the shoe, it says that the shoe development is not very important, but when you maintain the shoe, that means you have to wear it, you have to polish it. Okay, if there is any torn, you have to repair the tones and all. If the color fades, you have to do the recoloring. So that is what we call as the maintenance. Now software system says that whenever we do maintenance, sometimes it is more costly than the development. Now maintenance means, sometimes what happens is maintenance correcting errors that were not discovered during the production development phase. So when we are producing, say the shoes was built but it was not very comfortable or it's not up to the size, so we have to correct that size. Now this is called corrective maintenance. Okay. Now, improving the implementation of system and enhancing the functionalities of the system according to customers' requirements is called perfective maintenance. Okay. So if there is an error we found during implementing the system, we call it as, we correct the error, means it is corrective maintenance. Now we want to make it better. Okay, then it is called as perfective maintenance. Now we have to do, after that we have to do something called as porting also. See, when we develop the system, it was developed in one environment of Windows 8, but when it came in market, by the time there is a new operating system, it is come to Windows 10. So we have to make the system run in Windows 10. When we were developing in Windows 8, but by the time it came after 1 year, a new operating system has come, that is Windows 10. So that is called as adaptive maintenance. Okay, fine. So this is what we call as porting. Okay, so last part here is the disadvantage of this. Now as I told you, this cannot exactly handle the real time projects. Now real time projects means, as I've already told you, real time means the pilot has to take decision within the real time, that if there is a cloud ahead or there is a hill ahead, then within 2 minutes you have to take a decision that he will go above the angle of 2 minutes. Now if you try to wait and see whether the cloud will be there or not, then there will be fatal. So in real time system, what happens is the user cannot say what is going to happen, because the user is not sure. So in real time system, this waterfall model may not work. So most real life system cannot exactly follow the sequence of waterfall model. The sequence of waterfall model cannot work. So real time system and real life projects, they say that waterfall model is a bit disadvantageous. Okay, can you tell me can anyone tell me one more disadvantage of this waterfall model? I'll just give you a pause here, and till this phase, if you have any questions, you can ask me. So this is, I end the topic here. If you have any question, and can you just give me one more disadvantage of this model? I pause here. And for those students, I'll repost this video and you can get this link. And if the audio is not clear, just go a little bit behind, 5 to 10 seconds behind. Then you follow from there. And I'm giving a pause also in between. And now it's time for you to ask questions. In real-time system, what happens is the user. Okay, the last thing I'll tell you here is there's a disadvantage in this system is you see this one. If there is an error here in feasibility study case, the error goes next. If there is a mistake by here in collecting the requirements, it will go next in the design. It will become a wrong design, and further it will go and test and all. So there is no feedback from one system to another. The solution to this is we have an iterative waterfall model. See, from one phase, if there is any change, it goes back. Feedback is there, so it gets refined at every stage and comes down. That is one disadvantage of a waterfall model, which is there in iterative waterfall model. Now both are same. Only cases in iterative waterfall model we have a feedback. Okay, that's the only thing. So this ends my class. I'll post this video again in the link. You can check it from the link from live classes. Okay, I'll post it now. So in case if you have any live questions, you can ask me, or you can WhatsApp me, or you can put anywhere. Okay, in case if you have any questions here. So I stop here. That is one disadvantage of a